Hello, welcome to Physics Teacher. In this video, I'm going to go over a grade 12 physics lab on relative velocities. Now, the actual lab you can download for free in the description so you can follow along. We'll make our measurements and then you can do your calculations and conclusions on your own. So what we're doing in this lab is we have two cars that travel at slightly different velocities. The red one is a little faster than the blue one. And we are going to analyze 4 different situations. First one is going to be when they're moving together. Then when they're moving apart with the red one catching up. We will also do when they're moving apart but the red one getting further ahead. And we will also do when they're together moving apart. And we're going to have to figure out their relative speeds to each other. To start, we are going to have to figure out what their speeds actually are. Now here I have a measuring tape. I know you can't see the very fine millimeter divisions, but for this lab we don't need to be that accurate. So what I've done is I've placed masking tape at each half meter marking. So this will be our 0, 0.5, 1 meter, 1.5, 2, and 2.5 meters. So to figure out their speed, I'm going to turn them on one at a time. They'll go 2.5 meters, and you can time how long it takes for them to do that and calculate their speed. If you don't have a stopwatch or your phone handy, you can just look at the time bar in the video. Let's start with the red one. I'll do a countdown from 3. 3, 2, 1. And stop. And we'll do the blue one. 3, 2, 1. As you can see, the blue one is the slower car, but it'll make it there. And stop. All right, so our first situation is the cars are going to be moving towards each other. So what I'm going to do, so I'm going to place one at the half meter mark and one at the 2 meter mark. So they start at 1.5 meters away. You're going to time how long it takes for them to meet. Knowing that that relative distance they travel is 1.5 meters and figuring out the time it takes for them to meet, you can determine their relative speeds to each other. But knowing their individual speeds, I want you to first make a prediction before we do the experiment. So pause the video, do that now, and then we'll continue. All right. This tests how long my arms can stretch, but let's do this. 3, 2, 1, go. Now for the next one, we're going to have the faster car catch up to the slower. So we'll put the faster car at the 0 meter marking and the slower car at the 1 meter marking. So the faster car has to travel a relative distance of 1 meter from the blue car's point of view. Okay, so make your prediction what their relative speeds are, and then we'll start. 3, 2, 1. Now, all right, so you got that time to figure out their relative speeds. Now in the third situation, they are going to start at the same point, but they are going to be facing in opposite directions. Now what I'm going to do here is when the red car reaches the 2 meter mark, I'm going to stop the blue car. And then we can figure out after however recorded time how far apart they are. Make your predictions on the relative speeds, and we'll start. In 3, 2, 1. Now. Saved it. Okay, so when this got to the 2 meter mark, this one was at about 0.4 meters. So they are currently about 1.6 meters apart. You know the time it took for them to get that far apart, figure out their relative speeds. They are going to start at the same place. Let's go back to our starting line. And I will stop the blue one when the red one reaches the 2-meter mark. And then we'll see how far apart they are. And you can calculate their relative speeds. 3, 2, 1. All right, so when the red one made it to here, the blue one was here. So red was at 2 meters, blue was at 1.4 meters. So they are 0.6 meters apart. You can make your last calculations, figure out your relative speeds, see if they matched what your predictions were, and let me know what you get in the comments.